So no matter how difficult it is, but that was a good point. Uh, I'm just waiting to make sure that the live stream is started in the YouTube. And then, yes, done redirecting to the YouTube. Great. Now we are on live and everything is set. And since Martin could not join yet, Gilva, we are all yours. Just what should we do now?
We're going to present the examples. We have a wide range of examples from the simplest into the most advanced one. So I'm going to share my screen for starting for the simplest, and also gonna turn on my camera. Okay, here it is. First, actually, just a moment, please. Okay. I wanted to start from this modeling because showing this model is just to give you a glimpse of capabilities of the giraffe that you can work with. And actually, it shows the different kind of the modelings and complex one type of the geometries that you can work with the giraffe, but we just decided to skip this one, and because you know, this kind of modeling has been modeled with the different softwares, and we just wanted to use the native Grasshopper components. So we just decided to turn it into a simple example that I can share it right here for you with you actually. And we just decided to model it as a grid and just extrude each of the cells and show it as a parametric one, just to show you that actually with a track point that, let me find it, this one, yep, yeah, that whenever we just move it into the different dimensions, most of the cells are getting to be changed, and instantly you can also see that all of the charts are changing. So the purpose of this model was showing the ability of being parametric and being updated at the same time that you're changing your things. And also we just try to use the different charts just to show that with this kind of simple modeling, you can represent it in different kind of data. Such as here, this one is the bar chart that shows the height of the buildings. This one shows the highest, definitely actually. And this one is the scatter 3D, that the distribution of the points are actually kind of the model here. And this one shows the highest one. And we have the histogram, that here are the different criteria, such as edge color, aligned with and color. You can choose, you can change, just whatever you like. And this one is the pie chart, actually, that by connecting a number slider to the donut part, you can change it and just make it into the donut chart. So it's just the simplest one, and I will stop the sharing and just leave everything for next people to come and explain their examples.
Thank you. Thank you so much. Now, who's the next one? I think you're the panel manager today.
Yeah, so she's the next one.
Hello, everyone. I'm Sorush. I appreciate my friends for their presentations. Let's share my screen. Actually, I'm going to talk about importance of use the graphs, not teaching the algorithms or something like that. So I have a little presentation. This is the historical context of Yazd. As you say, there are some similar buildings with courtyards and vent holes. Uh, everything is very similar. So the architect, the only important points for designing houses were culture and context. So the architect designed the houses similar to each other, so that it was very natural because people uh, live the same as you see, and there were similar styles, lifestyles. But nowadays we can see there are different requirements, needs, and so that there are enormous data to handle. So we must work with high precision with data. And as you know, we have two types of data: qualitative data, like non-numerical data, and quantitative data. Our topic is talking about quantitative data. Uh, so, in quantitative data, we should manage our data, compare our data, and choose our data. So we need graphs. And in Grasshopper, we can use giraffe. Um, uh, in giraffe, we have an algorithm with three parts. The first part is the part that generates data. That and the second part is our part that can construct data with giraffe, and as my friends explained before me, you can know each part of these components. And the last part is save or visualization of our data. That we have some ways. The first way is use the components from Giraffe to save our data. That, as you see, you can save your data with a path and your format and things like that. And the second way is using Javid that Madyar explained. And if I want to show my examples, the first example is uh, visibility percent. It depends on the person location, and you can calculate your visualization. So as you see, we can compare our data. This data is a data tree that uh, shows the data of our grid, and the second is the average of uh, every person location visualization percent. In and I have one more example that I use kangaroo to show you the ability of kangaroo and giraffe. In here, we have a form that we generate with Kangaroo, and at the second part, uh, we can have our uh, radiation analysis. My problem was I need to compare the radiation at the different seasons. So I for compare that the number values was a little weird. So I used Jira for that. And what's the problem here? My toggle was false, but now is true. As you see, I have a comparison from my datas. This is the data of every single sensor of my grid on my shell, and this is the average of my datas at the different seasons. Um, that was the all. Thank you for your attention.
Sorry. Thank you. Thank you so much, Sarush. Thank you
Thank you
for your
so much,
explanation.
Azar. Thank you for your help. Thank you.
You're welcome. Okay, and Hilva, do we have you here?
Yep. The next person is Fateme Mohammadian.
Okay, Fatima Jan, if you're
Hello.
speaking, oh yeah, that's now we have your voice and also we can see your screen.
Okay. Okay. Let me just adjust that. First of all, hello everyone. It's an honor for me to be here today. My name is Fatema Mohammadian, and I'm a building science expert and a graduate with a master's degree in architecture and energy, also known as building science in Shaykh University. Uh, in this presentation, I would like to briefly present my master's thesis, which I defended about a year and a half ago, I think. The focus will be on the application of the Giraffe plugin in various stages of design and optimization within this research. I believe you have already gained a general understanding of how to work with the plugins and components from my colleagues' explanations. So I will focus more on the outputs and charts. And also hope this presentation helps us to better understand the diverse applications of the Giraffe plugin and how it can be utilized at different stages of our research. So let's move on. The subject of my research was shown in a previous slide, and we have here the research stages, which are divided into 5 main steps. And I will try to provide a concise and useful overview of how Giraffe can be applied in each step. Firstly, I would like to give a general definition of the term and concept of positive energy districts, or PEDs. With the emergence of sustainable city development, many governments, such as European Union or Urban Europe, have outlined new horizons for the future. So concepts such as low energy or zero energy buildings, and on a larger scale, zero energy districts have been introduced. And I believe around 2018, the concept of PEDs was articulated. So the key concept of positive energy districts refers to a district or area that produces a large amount of energy from renewable sources, and a part of which will be needed by the district, and the export will export the excess energy produced by to the district to other parts of the city or other districts nearby. And following this introduction to the design approach of this research, we move on to the first stage, which covers the theoretical foundations and research questions. For main questions were posed in this research, the first one was, what is the trend of energy consumption? Or what are the most effective methods of reducing energy consumption? And what are the most efficient renewable energy production systems for the district we have? And what are the most efficient optimization methods? For example, to answer these questions, and specifically first question, comparing the available data can be challenging. So therefore, I created this heat map to identify and compare the data I had, the primary energy consumption trends in various countries and continents using the heat map components of the Giraffe plugin. As you can see, the codes here and logos of the components here. In another section, to see the distribution of existing PED case studies in Europe and their in abundance, we can use the pie chart component of the plugin, and now we can see that Norway gained the first rank in this chart, which is have respectively 16% of the so let's move on in the second step, which involves analyzing of environmental and climatical conditions. We can utilize various charts available in the plugin. My colleague Soshan will provide more detailed explanation afterward regarding this part. But I was considering that not only architects and energy experts, but also other individuals with any kind of data can use the GRF plugin with minimal familiarity with Grasshopper. For instance, I created this donut chart to find the percentage of special division defined according to the client and project needs in my project. And we have here the codes and the parameters we can use for to creating these charts. Now we move to the modeling and simulation section. As you know, we can use various online tools or software and plugins depending on our project. Since this topic is kind of extensive for this workshop, we will skip this part and proceed to the crucial part of reviewing and analyzing the results we have from simulations. In the following slides, I have tried to generate the results of various sections, including energy, lighting, and comfort indicators using GF plugin based on pre-existing data I had from last year. As you can see, these customized charts make it much easier for me, especially, to compare the results. And you can see here we have line and bar charts.
So is it just me or we are all missing Fatima? Yes, Fatima, can you hear me?
Yeah, unfortunately, we lost her.
Okay, we have her
Mm,
desktop, but
no.
cannot hear her. Maybe just let us wait for a couple of minutes to see if we can have her back.
Sorry, I believe I've disconnected.
Yes, yes, we're just connected. We were waiting for you. It's good to
Yes,
have you back.
I'm so sorry. From where I should start again? Which slide I was
Great.
on. Can you just tell me where I should start again? I would really appreciate.
Great, go on.
Hello. Okay, let's move on. Okay. Um, in this slide, we examine wind comfort for pedestrian in two different models, each with distinct features specified in the table design. And we have options features here for neighborhood units. And finally, in this section, we analyze the energy consumption of various facilities in the district and simulated and predicted, and also compared them with standards such as Iran's international standards, EC++, and ASHRAE 90.1. Fortunately, we observed significant energy saving in this part by employing efficient methods in part of reducing energy consumption. And to achieve the main goal of positive energy balance, we needed to examine the potential of hybrid renewable energy systems. So we investigated three systems, three different options, which combine a combination of photovoltaic systems, CHP, and wind turbines and heat pumps. And after simulation was done, I initially generated scatter plots for the energy indicators of one of these systems. And furthermore, to demonstrate that non-architectural data can also be visualized using graph, I reviewed and predicted the economic outcomes of this system over the next 20 years, including indices like MPV here, revenue and cash flow. And we can see various charts with various kind of visualization of data here. And finally, for the next step, the part I find most fascinating about is optimization. Here we have optimization process flowchart and some random models generated with the code. I saw here a residential unit where the gems included the WWR for each direction, the form of shading devices for each window, and the angle of the solar panels as it's shown. In the main project, about 500 models were examined, but for this workshop, we ran the optimization problem with about 20 generations and 10 individuals, totaling 200 iterations using the Velocity plugin. And here we have the main code for multi-objective optimization and the selection for sections for energy consumption simulation, energy production here, and other indicators like CO2 emissions. But I really like to skip this slide as soon as possible. And after the optimization time ended, and we had the data, I wanted to play around with the results a bit more. So I trying to produce other charts using graph components, and notice that from around the fifth iteration generation, the UAI here and CO2 emissions results were converging, while this convergence did not occur for PV panels energy production. And additionally, using a 3D scatter plot, I gained an overall view of each model's position for these three indicators, and hoping to identify whether we had approached to optimal model within these 200 iterations or not. Now you can see random samples of the results and optimized models. And finally, we have final design here of positive energy district on Laban on land, one of the Persian Gulf islands in hot and humid climate. Here is also a diagram of the energy system, including the energy consumption for each facility and production of each section. And let me share my code here. And of course, the Grasshopper script we have here have been thoroughly explained with my friends. Here we can see my samples and examples and how they can be changed in different parameters. And maybe we can change everything here. The width and the line types, or here, let's do this. The 3D scatter plot components, and you can change it in other views and have a comprehensive analysis of this. So that's it. Thank you for accompanying me. I hope you enjoyed these examples.
Yes, thank you. That was great. Thank you for presenting your master thesis for us, and thank you for applying Giraffe to your analysis. So, who is next now?
We're gonna have Mahsa Malik Shahi.
Great, Massa, can you hear me?
Hi. Hello, everyone.
Hello.
Right. Can you hear me? Okay. Let's
That's
share my
great.
screen. Okay. Can you see my screen?
Yes, your voice is clear and we can
Okay.
see your screen.
Okay. Hello again. Hello, everyone. I am Mahsa Malikshahi, one of the developers of the Giraffe plugin team. I want to explain the advantage of Giraffe in data analysis in my field with a few examples that is not the same of my colleague usage. As a co-founder and designer of SWAT Electronic Security System Company, I design electronic protection system in mainly industrial projects. Our project consists of multiple components such as data that must be analyzed and controlled for optimal design. And this information is provided to the client to explain the justify of the design. This map you see is a sample of design that we deliver as an output to our client alongside several Excel files and contain the information and values used in the project. It can be seen that understanding, analyzing, and separating data in this design is complex, especially since clients generally don't have technical knowledge of these subjects. Totally, our projects are divided into three main sections you see here. First is infrastructure such as various fiber optics and cables. Second is poles for installing security equipment. And third is security equipment such as cameras, protection, perimeter protection, and paging intercom like so. In this design, we have the important each of these items separately from Rhino model into Grasshopper. This is where Giraffe help us to extract and analyze the desired information for the design. Here we see the input options here, input data here that we have these from Rhino as a geometry, curve lines, etc. And then we have the Giraffe components here, and then we see the plot with Javid preview bitmap here. Now we go for first example. We have ring types here as a curve, and I put these rings in 4 types, and what needs to be optimized is length of these rings or lines. I have the total rings because the line in these components are separated in our site, and we have to find the mass addition of the total lengths. We use the mass addition components, and then we have the 4 items lengths here, and then we have bar charts. We have the Giraffe component bar charts here, and we can see the lengths of each rings in each types here, and with this data we can compare the lengths of each rings and have a good result for a lower cost of our projects. In this section, we have power cable data that we put them again from Rhino and in curve type, and again what needs to be optimized is the length of the power cables, and we do this algorithm again with this length, and we can compare the each power cable length here, and also we have pie chart here for each percentage of the cable used in the project. With this total data, we can analyze which part of infrastructure imposes abnormal cost on the project, and if needed, interactively make change in our model, and we can see the result in the chart and make the best decision for our designs. Next section in our project are poles. We have 2 poles here. I put 2 type of poles here, 6 meters and 12 meters. but we have more than these in our plans, in our site plan. But for this presentation, I have two of them here. I put them in a geometry type from Rhino file into Grasshopper, and then find their location with a point component, and then give the point into a scatter to the component of giraffe, and we can see the scattering of our camera pole in our site. We can see the where area have a debut of poles, and we can consider if we are in overestimate and over design, and we can control this and the cost of the project also. Also, we have here a 3D scatter plot from giraffe. We can give the height of poles to this point, and extract them from here, and put them to a scatter 3D component, and give a good view to the designer and the client for to consider and understand and imagine where the equipment are located, and they have a good view of these. And I just mentioned that I should mention that we have these scatter 2D and scatter 3D in one plot, and we can see the scattering of the 3D view of them. Also, we have bar charts here that we can compare the quantity of pole, and we also in next steps we can have a cost of the project, and we can consider and have a best decision for our project here. In next example, we have camera types here from our protection equipments, and we have 8 of camera types here. We are put geometry in our Grasshopper file. We have the shape of camera here and put them in geometry, and we find their location with a point component. Then as we see, we have the scatter 2D here, and we have separated color and marker for each type of camera, and we can scatter them again, and we have the location of the of each type of cameras here. And with this plot, the client can have a good view of our locating, and have a good desire, have give us a good desire of they wants. And the end of this analysis is the quantity of the camera and in our project, and we can compare the cameras and have a balance to any type of cameras. If we have a type of camera in more type of camera in our project, we can reduce them and have a good decision for this. For these designs, as we see, without giraffe, the past achieved these goals was more complex. This information was extracted as a CSV file and analyzed separately using Excel and Matplotlib in our projects. And now entire process is done within Camera and Grasshopper. Also, a designer can make the necessary changes interactively to design, and quickly and efficiently see the results in the output charts. It makes saving a lot of time, reducing the possibility of errors, and greatly aiding the designers in optimizing the design. And another very important point is that presenting the design to the client, there is no need for designer to be present in the meeting and explain the design and the complex influencing factors that client can understand the dimension of design by seeing these charts. Thank you for your attention.
Thank you. Thank you, everyone. Thank you, Massa, for your explanation. And thank you for showing us that we can use Giraffe as a data management plugin in other projects rather than architectural design. And to all participants, thank you for following the session till now. I know this is the end of time of our session, but since we have one, two example, I guess, that the team put a lot of effort to make it ready for today. Please let us continue the session. If you want to leave the session, I understand. You can later catch up with a video, but we're continuing the session to record all the examples in one session. So. And please, again, someone's microphone is open accidentally, actually. And yes, okay, I think I catch that. Great. So let's continue on our, is it our last example or we have one more after Sushiant?
No, we also have the next one.
Okay, so
One
let's continue with the next one is Sushiant, yes? And she has a very, and he has a very good examples on using Giraffe in, I guess, in a energy efficient design plugin. What was the name? Ladybug. Yeah, the Ladybug. Okay, Sushiant, can you hear me?
Is he online? Because I can't see his profile.
Yes, apparently he's not here. And what about the other one? I think after Sushiant, we should go with Matin, yes? And Matin is not online either. So I think our team, so I think our team is in the workshop much sooner than the participants. Okay, so great. I think this is all. This is all we can have now. Since we don't have Sushant and Matin. Maybe they can record their own examples later, and I will upload that in the YouTube channel as well as the other workshops videos. So thank you for being with us until now. We will see you tomorrow. Please, if you can, please work with the Giraffe plugin and report any bugs that you will face with or anything else you think that can be better, anything, any improvement that you think we can have in that plugin. We will be more than happy to hear from you. And also tomorrow, our last session will be the first tomorrow, our last day. The first session will be sum up everything. We will sum up the optimization, and we will dig more into exploring the data and how to get the data out of the optimization black box, how to apply Giraffe for better understanding of our optimization output. And the final session will be all your session. You can just introduce your problem, your problem definition, your optimization problem, and let us know if you need any guidance in defining your problems or running your optimizations. So see you all tomorrow at the exact same time again. Have a good day or night. Bye.
Thank you.
Bye.
Bye bye.
Good.